So at some point of PC building, you must have come across the term thermal paste, and you might have wondered, why do we need this thermal paste in our computer? And I have the answer for you. So first, let's talk about the primary components in a PC. Now first we have the processor or the CPU. Then we have the graphics card, also known as the GPU. These are primarily the most power consuming components in our computer. Now what happens when a component consumes a lot of power? Some amount of this power is converted into heat. Now this heat, it needs to be dissipated away from this case. And this heat we are talking about, it could be in the range of over 100 degrees Celsius. So with great power comes great heat. And now this heat has to be dissipated. So what do we need to dissipate this heat? That's where cooling solutions come in. The two most common types of cooling solutions we have is the air cooler, and then we have the water cooler. So air cooler is generally more economical and the most preferred method, since that's what most manufacturers supply along with their product. Water coolers are generally reserved for the more higher end products or for the enthusiast community. So let's see an example of the air cooler. Here for example, I have the Intel stock cooler for the 4th generation i7. You must be familiar with this stock cooler which comes with most Intel desktop processors. Now this is a basic air cooler with a heatsink at its bottom and a fan at its top. On the base of this heatsink you can see that there's a round copper plate. Now it's covered with a thin layer of thermal paste that was previously applied on this, and I have not taken it off for the purpose of this video. This copper base plate is the area which will come in contact with the processor or with the top surface of the processor. Now the top surface of the processor, it's called the IHS or internal heat spreader. The internal heat spreader acts similar to a heatsink and is what takes away the heat away from the chip found inside the processor. As seen outside the processor, a similar thermal paste or a thermal interface compound is present inside this processor as well, directly on the die, between the die and the IHS. So what exactly does the thermal paste do in between these two surfaces? Now as much as these surfaces seem to be smooth, they may not have 100% contact. So why does that happen? This is due to the microscopic gaps or slightly larger gaps in between these two surfaces, which prevents 100% contact. Now without this 100% contact, there is a loss of efficiency in transfer of the heat from the processor to the heatsink. So we need to maximize this efficiency, and how do we do that? We fill these gaps, and that's where the thermal paste comes in. This thermal paste lies in between these surfaces and fills all these tiny gaps which cannot be seen with the naked eye. So now we have that sorted. So what is the difference between the different types of thermal compound available in the market? Are there any differences? Does it matter which thermal compound you choose to apply in your CPU or on the graphics card? The primary factor to consider when you are looking for thermal paste is its conductivity. Now the conductivity is generally measured in watts per meter Kelvin. This value is generally found on the specifications of your thermal paste. Now here I have the Cooler Master Gel Pro, and on it we can see that it is rated for 8 watts per meter Kelvin. This is the conductivity of this thermal paste. Simply speaking, higher the amount of this conductivity, higher will be the efficiency of heat transfer, and hence more heat will be dissipated faster, or at least that's what it's supposed to do. Okay, so now that's out of the way. You know what thermal pastes are for and why we need them. That's about it. That's thermal paste and why do we need them. So now that you know why do we need them, you probably want to see how to apply them, and I have also made a review of the Cooler Master Gel Pro, which I have right here. So in case you want to see that, you can check it out here in the link which I'll be providing in the description, or probably right over here. That's it. Until next time.